So yeah, hi everyone, welcome back to our daily LeetCode challenge series. So today is day 78 and today we're going to solve LeetCode problem 101 symmetric tree. Okay, so this is an easily problem. So we have given a root of a binary tree. Check whether it is a mirror of itself. So it's quite similar to yesterday that we have seen the example right in the last video. Okay, so symmetric around its center. So basically we have given one binary tree. We have to tell if there is a left node is value is equal to the right node value, right, and the vice versa, and the child is also equals to the child of right nodes, right, leaf nodes. Here we can see example 1, we have the parent node 1 and the left child is 2 and right child is also 2. Furthermore, like 2 is having 3 and 4 in the left and right, and 2 is having 4 and 3. So in the mirror if you see, so left should be equal to the right one and right should be equal to the left one of the opponent leaf node, right? So in this case we can say it is true because this is a mirror image, right, of binary, or we can say symmetric, right? In example 2 we have given like 1 as the parent node, 2 is also same, so it's fine, but their child I can see 3 is at the right side. Even for the right one, leaf node is having also 3 in the right side, so that is not a mirror, right? That's why it's false. Fine. So we have given constraint the number of nodes in the tree is in the range of 1 to 1000. Fine. And value can be range from -100 to 100. Okay, fine. So in the follow-up we have given, could you please solve the both recursively and iteratively? Okay. Anyways, like a tree, mostly I prefer to solve with recursively approach only because there is a symmetric way, like we have to call and check the things. So better approach we go with the recursively approach only, right? So even for this case I'll go with the recursion. So what we'll do here, we have given the method symmetric which is having the root node. Okay, so best case we can say, like if root node itself is null, then ideally it is symmetric only, right? If one is single node we have, even we can say that it is a symmetric or like mirror image, right? But when we go to the child part, we have to check their left node and right node as well in order to check whether that is a mirror or not. Okay, so what we'll do, we'll create one helper function. I'll remove this for now because we same definition we have given the binary tree in the complete LeetCode, so it's basically I remember that one, so fine. So what we'll do now, first of all we'll create one helper function. I'll take this as reference, and isMirror will say isMirror as a mirror, like it's my helper function. Here we will take left node we can say, and same tree node for right node, right? So we have to compare this part whether it is equal or not. So in comparison what we have to check, we'll check the base scenario. If left node is equals to null, right, or right node is equals to null. So in any case if both is null, then we can say true or we can say false, right? So in order to differentiate that, what we'll do simply here, we'll do left node equals to right node. So if any of one is null, then we can simply check their value and return true or false based on that condition, right? Because there will no further either in the right side or the left side. So this is the base case. Second case, what we can check here in order to check whether the mirror is merged or not. So we'll do left node dot value, right? If it is not equals to right node, right node dot val. So if left and right value is not equal, what we'll do, simple return false. So this is the base case in our scenario, right, for checking the mirror. And last we can call this recursively to check furthermore childs of the given binary tree. So in that case, what we'll do, we'll simply we'll simply call this method and we'll pass left node dot left side, which should be equal to the right node of right side. So we'll pass that node right dot right. So here you see, like let's suppose this is our child node. We are passing left node of left, it should be equal to right of right. That's what I've written. Similar way, we have to check left right node with right left node. So that condition also pass here. We'll call recursively and check, right? So I'll let me add here, so for better clarity. Fine. So here we will check left of left nodes right value with the right nodes left value. So any of this one, if get failed, so we will get the false value, right? And if everything is fine, then we are going to have the true value. Okay. So I'm basically here I'm calling recursively, right? Here you can see. Now what we'll do in the main function that we have given, main method, we'll see check the base case. If root itself is null, then we'll return null, true, right? Else we will call this method with the child node of the parent or leaf node, you can say, right? So here we'll pass root dot left and root dot right. Fine. So it will call this one and it will check recursively for all the nodes. Fine. Now let's submit and see. Okay, I think there's some spelling mistake, right? RHEST, my bad. Let me check other places as well, so no more errors should come. That looks fine. Let's submit. Okay, so our both test cases got accepted, as you can see. Fine, let's submit and see other test cases as well. Okay, so all 200 test cases got accepted and beats 100%. That's quite good, right? And even based on the follow-up, they are asking for recursively approach, so we did that part only. Fine. So yeah, here if we talk about time complexity, so for time complexity we can say it will be big of n, because here we are like visiting every node of the binary tree, right? So n is none other than the nodes of the given binary tree, and a space complexity we can say the amount of height that we are going down. So h we can say the depth of the binary tree. So that is the space complexity we are going to use, because we are calling it recursively, right? So that is big of h. Fine. And there are other solutions as well, like using stack. We can also check this scenario. If you know any other solution than, then you can comment it down. So that's all for today. Let's see you next video. Bye.